you thought you saw the last of this compact disc 5-disc changer. Not a chance. It's a perfect training tool here, and I'm going to plant a few faults in this unit and show you some of the more common problems that we encounter with these 5-disc changers. One of them is a mechanical alignment. In this case, people move them, they drop them, they bang them around. It gets out of adjustment. As you can see, I can open up and close the drawer, but it won't open on its own. It'll just sit there and jam. It'll open and it'll go closed, but it won't close all the way. What happens here? Well, this is a mechanical alignment problem. Obviously, it's not going to play. So what we have to do is we have to get the alignment of the gears back. And there's a procedure to do that. We have to align the gears. Now, in this position, we know that this should be fully back. The problem is, how do I get it fully back? Well, there's a couple ways to do it. Probably one of the easier ways of doing this is there's a screw on the side here, and there's actually a hole in the side of the cabinet. You can release one of the side brackets here. I'll show you. So we release the side bracket here. We can now lift the unit up and should be able to drop it into position. Like that. Okay, now we can put the side piece back in. Put the retaining screw back in, and this unit now should open. Which it does. That is one problem that you'll encounter with these machines on a regular basis. I'll show you another problem that happens quite frequently. And this can be a couple of different things. So let me just set this one up here for the next problem that we've got. And I'll show you usually what causes that problem. So here's problem number 2. You turn on your disc player. And the turntable just rotates back and forth. Very common problem on these units. And I will explain what's causing the problem. On these Sony disc players, they use 2 optical sensors. There's one optical sensor which is right down, I believe it's right here. I'll show you with the camera. So there's one optical sensor there. You can actually see it emitting an infrared light beams. You see that? The purple light that's in the slot? That's actually a sensor that detects if there's a disc in. That's how the unit knows. It detects the silver of the disc. That's how it knows that there's a disc in that spot. There's also another sensor underneath the turntable assembly that reads the position of the disc. Now, even if we eject the tray will open, but it's still doing the same thing. And generally what causes this is there's a flexible ribbon cable. I will show you it. So here's our flex cable here. This interconnect cable connects between the rotating tray and the main circuit board. And it carries a couple signals. It carries power, and it carries the motor voltage to turn the turntable one way or the other. It also carries the signals from the optical sensors that provide the feedback to the deck as to what position the turntable is in. And what happens is this this cable here, these have a real tendency to break, this flexible board. And when they break, if you're not getting the signals from the optical sensor, it's going to behave like that. Another thing is it could be the optical sensor that's bad. One way to tell is we can put the scope on it and see if we're able to read the signals from this sensor. So as you can see, I have no signal being fed off of my optical sensor, and the reason why we have no signal coming from my optical sensor is, well, my optical sensor has been bypassed just for this demonstration. But what we would normally see is we'd normally see this swinging up and down between 5 volts and ground as the optical sensor is passed. So I'll show you it in normal working condition. So this is the optical sensor here, and what it does is as the turntable rotates, you'll see on the bottom of here there's a series of slots, and these interrupt the beam, telling the microprocessor exactly as it rotates where it is. So if that sensor stops working for any reason, you're going to get that symptom with the turntable just turning back and forth. What I did to create the fault was I just placed a little piece of black tape across the sensor so that there was no signal being read. A broken ribbon cable was the most common. I mean, these sensors do fail, for sure. They do fail. Most common is the ribbon cable that goes bad on these things. That's the most likely problem, other than alignment problems, on here. And this is the other sensor. This is the disc in sensor. As it passes past the optical pickup, that's the sensor that is going to be read as to whether there's a disc in place or not. So I've now just put this sensor back in service, and we'll reassemble the turntable assembly, and I'll show you what the output of a properly functioning system looks like. Okay, now it's reading the disc. As you can see, it's slowing down as it approaches each one. That's when it's looking to see if there's a disc in place or not. We'll open the unit up, and I'm going to scope the output of the cable here, and as I rotate the table so you can see the pulses on the scope. Okay, I'm going to scope pin 4, counting over from the left here. So it's the 4th pin over to the right from this position. So we'll turn the camera around so you can see the scope. And as I rotate the disc, see the trace jumping. I'll just give it a bit more voltage here so that there's more swing, so that you can see. Maybe we'll speed this up a bit because I know the rolling shutter on these cameras makes it hard to see, but you see? If I slow it down just a bit, I'll try and see if we can make it slow enough so you can see what's going on. There you go. So if you don't have that signal on pin number 4, counting over from the first pin, which is indicated by the dot, so on the looking from the front on the left side, pin 1 is on the left. So it's pin number 4 is the pin that receives the signal from the optical sensor. If you don't have that signal as the turntable rotates, you will never ever ever have the unit play. Now let's look for the signal that's from the other optical sensor, which I should be able to see when I put the disc actually in. That's it there. It's pin number 2, and as I move the disc away, you'll see it goes low when there's a disc. We'll just drop the voltage down a bit. If I take the disc away, there you go. Voltage goes up. When I take the disc away, voltage comes down. There we go. No disc in place. And as the disc rotates into position, see the voltage change? Goes up. Take the disc away and it goes down. That one's pin number 2. But pin 4 is the one that you're going to be looking for here. Looking for the signal. So here's where I'm scoping between ground, the 4th pin over. So pin number 4, it's hard to see when I'm looking at my TV screen. Pin number 4, when I rotate the discs, that's our data that tells the unit what position each of the trays is in. So if you've got a unit that's hunting, it's going to either be the optical sensor under here, or it's going to be this flat, flexible ribbon cable. The most likely culprit is the flat, flexible ribbon cable. That fails 9 out of 10 times. It's going to be that flat cable that's causing you the problem for disc hunting. Now if the disc tray doesn't turn at all, well, that cable could also be severed. So if it doesn't turn at all, you got to check for your voltage on there. It's either going to be the belt on that little motor. The little motor itself could be shot too, very unlikely, or it's going to be that flat cable, because that also carries the motor signals to the turntable motor, the carousel motor. So if that goes bad, you're going to have that same symptom of the tray not turning at all. Other than that, these units here they don't have a lot of problems other than the alignment, which I just showed you how to do that. I actually should take this tray out and go through the full mechanical adjustment on this, because there are some alignment marks on the gears here. First thing you should know is that there's actually two modes that the disc drawer can open. There's a play mode where it's called disk exchange, and then there's the fully open mode where it stops playback. There's two separate buttons, one to open and close and one to do disk exchange. They're very similar in how they operate, but it's a double cam gear. This is our optical block. Our optical block is now in the loaded position. When you press the disc open, it drops the optical block down. The motor turns counterclockwise here and the disc tray comes out. When you load it back in, disc tray goes in, optical block goes into position, and the motor stops. If the motor continues to rotate to the right, the disc tray will come out with the disc still clamped in position. This is to allow you to exchange the 4 discs that are currently playing. Now, how does the player know what mode it's in? Well, I'll show you. There are a couple of more switches that we have to address on here, which are actually on the top side of this chassis. So I'm going to pull the actual deck out so I can show you these switches, because these switches are also a major source of problems. To open up the front, take the front the front panel off, you have to remove these 2 screws and 3 more on the bottom, and then the panel will lift off. Now you got to be careful. There is a ribbon cable on here, and these cables are quite easily damaged. And I, of course, disconnected this one on the bottom here by accident, but that has to be reconnected before we put it back together. It's one of the reasons the bottom has to come off. We're going to take out the screws on both sides here to open up the disc tray assembly. So we're going to remove that screw, and the 2 on the other side that hold this other bracket in, so that we can lift this entire piece out of the way. Looking at the bottom of the disc tray assembly, this is the ribbon cable I was referring to that quite often goes bad. Another problem that we do run into from time to time on these is solder connections on these optical connectors here, these optical pickups. This is your disc sensor that determines whether there's a disc in the play position or not for the optical pickup, and this one's the optical photo interrupter that counts the pulses as the disc tray turns. It's this one here that I blocked the signal so that it wouldn't read it. You can have a connection problem on here or here, which will cause, if there's a connection problem on here, it just won't read. It'll go to all the discs, but it won't pick a disc up if this sensor fails, or if you have a connection problem. If this sensor fails, it will just sit there and spin, as it will if the conductor for the optical pickups fails in here. If this cord gets severed completely, it won't do anything. The motor won't turn. But on to the main part of the chassis. The main cam gear. When the cam gear turns, to open and close the mechanism, we have to make sure that we are in proper alignment before we put it back together. That's critical, because if we're not in proper alignment, the unit's never going to work. So I've now turned it out of alignment. How do I know when I'm back in alignment? Well, I'm in alignment full closed when the optical chassis is raised. That's all controlled by this one cam gear. So the optical chassis is now closed. This is your normally fully loaded position. Before the loading gear, this is the gear that drives the chassis back and forth before the loading gear starts to turn. Now you'll see when I'm ejecting it with the CD unloaded, it's actually the teeth here is actually what moves. This gear does not turn. This gear freewheels at this point. It'll spin. You'll see it turning as the tray opens and closes, but this gear is not doing anything. It's being driven directly by the teeth on the side of this loading gear. So these teeth here, once this is pulled in and the transport raises, the disc is locked in place. And then it starts to eject. And then once we get to the position where it's going to release the mechanism to eject the disc for exchanging, then another set of teeth on this main gear drive this other plastic gear. So we want to take the chassis right to the point where the disc tray is loaded, it's locked in place, this gear can still freewheel, and where there's no contact. That way, at this point, the chassis can actually slide in and out. It's locked in place by this lever here. But we want to take this down further than here, so I'm going to remove these two washers so we can see what goes on underneath the chassis here. So if I lift up this nice grease covered gear, you will find that there is an encoder switch underneath here. It is keyed so that it can only turn by in one position. This is an encoder switch that's not unlike what you would find in a VCR. As the cam gear turns, this encoder switch also turns. Tells the microprocessor what mechanical time this gear is in. If this switch gets dirty, and they do, the machine will not know whether the disc is in or out, and you could have a tray that's going back and forth, and that's a common problem when these encoder switches get dirty, is that the tray will actually kick back and forth. And we can open this switch up and clean it just like we would on a VCR. So let's do that while we've got this machine apart. No time like the present. So I'm just going to unplug the encoder switch from below, if I can, and take it out. That's the motor control, that one. Here, I'll just zoom the camera back so you can see what I'm doing. So the white and red wire, that's to drive the motor, and it plugs into this other main plug here on the encoder switch. We'll just undo those. That way we can remove the encoder switch and clean it. We'll take out the encoder switch, just lifts out. Just like that. And we should be able to pop this thing apart. Kind of like we did with the VCRs. The VCR switches, this one we're just going to press a couple of little tabs here on the bottom, and the switch should pop apart like that. And here we go. Just like an encoder switch in a VCR, these contacts do get gummed up and dirty. We're going to wipe them out, clean them up here a bit, and put it back together. Clean them up, put a little bit of grease in there, put them back together. Now, another type of grease you can put on these things, you can use neutral, or you can just use any type of good, like Molly Coat grease. Anything that's going to lubricate the contacts, keep them clean. Doesn't have to be anything special. White grease, yellow grease will work. Don't use the black molybdenum grease, it's conductive. Or you can just use contact cleaners such as neutral. that'll work just as well. Put the switch back together, spin it a few times, and we're ready to drop this bad boy back in and reconnect everything. So we'll drop the switch back in. Really only goes in one way, so you're not going to make a mistake putting it in. And we'll put the screw back in to hold it in place and reconnect our wires on the bottom, and then we can go ahead and reassemble the cam assembly. So the mode switch is back in. Reconnect the wires and the motor like that. Now we need to put our cam gear back in place. Remember, our alignment has to be correct for the cam. And there is an alignment hole right here. And there's also an arrow that kind of points the direction it goes. Release our little catches here, and this piece will drop back in place. Now we can put our washer back on and do the same for the gear and find the other washer that we just dropped. Nope, didn't drop it. It stuck to my hand. It stuck to all the grease on my hand. And there, our alignment is correct. The cam switch is, I believe, turning. I'm just looking to make sure that it actually is engaged and turning, which it is. You can see it. So we find our home position, which is there. Mechanism is raised. The idler wheel is freewheeling. And now we can go ahead and reattach our disc tray. So we get our disc tray again. We have to reconnect the interconnect wire. And we should be able to just drop our disc tray in place like that. We can confirm that it's working by just turning the pulley on the bottom and make sure that it opens. And when the tray drops, it ejects. Okay. Now we know our disc tray is in position. We can go ahead and reattach our locking brackets in place. And of course put a couple screws in to hold it, and then do the same with the other brackets, and then we can reassemble the front on the unit and test it all out. Same goes for this other piece. Just goes on just like that. more screw. Now our cassette, or why do I keep calling it cassette? Our disc tray is locked in place. We can put the front control, button control and front face on the unit. Again, it just slides in place like that. There's a couple screws that go down on the top to hold it in place, and 3 screws on the bottom. Then we can reconnect our ribbon cables, and at that point the unit should be workable, if I've done everything right. Careful if you operate these units without the metal bottom cover on. And the reason I say that is if you look here at the back of the circuit board where I'm going to zoom the camera in, you've got live mains power right here on the board. Yeah, I can stick my finger on there because I've got the unit unplugged. But just keep in mind that you've got your 120 volts if you live in North America, 240 volts if you're over in Europe. It's live on the board. So if you're going to operate this thing apart, take caution that you could cause a short. If you put it down on something metal, for example, you're going to have major sparks. And you're probably going to have a unit that doesn't work after that. So we'll reconnect our ribbon or flexible PC board here and the other one on the front. Like that. I'm going to put the base on this thing for safety. Turn my amplifier on so that we can test this. I probably noticed my light just came on. My work light here is actually tied down to the switched power on my bench amp. Another unit that I recovered from the garbage. All this good equipment that people just toss out, it just never ceases to amaze me. You get all this good equipment that people just don't want it anymore and they just throw it in the garbage. And we'll eject, and we'll just load a disc. Any disc, can be anything. Press play, and it just spins, and the disc plays. There we go. It is working. Now remember I said this unit had disk exchange. If I press the exchange button will allow me to, and it actually moves. You notice that it moves it so you can access 2 disks at the same time. Now if I hit disk skip, it'll rotate it to the other 2 disks, so I can change all 4 disks. When I press the exchange button again, it takes the disk back, takes the tray back in. Now if I were to stop it, open it, it'll drop the disk and the tray opens, but you notice that now it only gives me access to 1 disk at a time. And when I press the disk skip button, 1 disk. Close. Play. It's going to scan the disks and see where there are disks. And I hit the exchange button. It rotates into position so that I can change 2 disks. That was pretty ingenious, and I like these. I like these disc changers that Sony had. I've got a 200 disc changer that I use on a regular basis. I'm kind of a little old-fashioned here. I still prefer to have my music on a disc, as opposed to. I mean, everybody's got their music on their computers or their iPods and stuff like that. I just find that uncompressed, full uncompressed PCM sounds a lot better than overcompressed MP3s. I'm not a big MP3 fan other than, say, to listen to stuff in my car on my memory stick, but I still prefer to use CDs. And there you go. So that's how to align and service one of these 5-disc changers. We'll catch you later.